All right, so here's the first problem that was sent. We're going to find the equation of the line shown here. So we're going to look at the line and see if we can find some points to figure out the slope and to figure out where it crosses the y-axis. So I'm looking, and the first thing I see is that there's an intersection here at 4 and -1. So that's my first point, 4, -1. And I'm going to look and see if there's another intersection point, and there is at 2 and -6. So I could actually count if I wanted to find the slope, or I could just use the math. I think what I'm going to do is just use the math. So that's going to be -1 over 4 minus -6 over 2. And this is going to be +6. So this would be 5 over 2. That is my slope. So we start off with y is equal to 5 over 2 x plus b. Now I'm going to pick a point. I think I'm going to use this one just because it has a 1 in it, which makes the math easier. So I'm going to substitute that in. This is -1 is equal to 5 over 2 times, turn that into a fraction, 4 over 1 plus b. So I have -1 is equal to 20 divided by 2, which is 10 plus b. So I subtract 10 from both sides. -11 is equal to b. So I can go back and put that in and rewrite my equation of the line. Y is equal to 5 over 2x minus 11. And that would be your solution. That's how you would find the equation of the line. So start by finding the slope, right? Find the slope. And in order to find slope, first you have to find 2 points. And then either count to find the slope or do the math to find the slope, okay? So second, you insert the slope and 1 point to solve for b. And then your final step is to write the equation with slope added for m and b. All right, that is what those are the steps you do, those 3 steps every single time. Find your slope. So first you find 2 points to find the slope, then you put the slope in, then you insert a point to solve for b with your slope, and then you write the equation out just like we did here. This takes longer to write than it does to actually do. Let's look at the next problem. All right, so this tells us that we need to find n. Okay, so right here, we've got to find one of these angles so we can find the other. In order to do that, I've got to use what I have around me to decipher. So this is a straight line right here, this line right here. So because it's a straight line, and I know it's a straight line because it says it's parallel to this line, and a line has to be straight to be parallel. So this has to equal 180, these 2 angles added together. So I'm going to call this x just for now. 114 plus x is equal to 180. I subtract 114 from both sides, and x is going to be equal to 66. Okay. So that means that if this is 66, I know that this angle here is going to be congruent to this angle here because they are at the same transversal across the parallel lines. These angles are congruent because they're hitting the line at the same angle because it's a straight line. So if this is x, this is x. So this is 66 degrees, and that's what I meant to write in here instead of x. So this is 66, and if this is 66, that means this is 24. Excuse me. So now I have my interior degrees, my angle, and I can use my trig functions in order to find out what n is. So I remember SOHCAHTOA, just because it helps me see the formulas, and it's easy to remember. So what I need to do is I need to find this angle relative to one of these axes, or one of these angles, or this side relative to one of these angles. Sorry, it's too early in the morning. So let's see which formula would do that for me. I could use 66, and I could use SO, or sine. That would be the opposite over the hypotenuse. Let's do that one. So that would be 100 times the sine of 66 degrees would be equal to n. And how I got that was I took SO, right? Sine of 66 is equal to n over 100. And then I multiplied both sides by 100, which canceled that here and put it over here. Okay, so that's how you do that. You just go ahead and take what would be in the denominator and multiply it times what's on the left. And then leave the numerator as your value on the right. But that makes it easy to do the calculation. So we just pull up the calculator and we say, let's get the big one out. We say 66 sine times 100. Round that to two places. That would be 91.35 is the value, or the length of n. That's your answer. Let's look at the next one. All right, in this problem we have to find n, a, b, and m. A and b is going to be pretty easy. We know that this is going to be 180. 160 plus b is 180. We can do some quick math in our head. 180 minus 160 makes this 20 degrees. All right, so if b is 20 degrees, this symbol says that b is congruent to a, so that means that a is 20 degrees. So easy math. There we go. All right, so if a is 20 degrees, this is perpendicular, we can fairly assume, so this is, otherwise we wouldn't be able to do the problem. It has to be 90 degrees. So this is a 90 degree angle. So if this is 20 degrees, then this has to be 70 degrees. All right, so there's our degrees of measure. And now we can use SOHCAHTOA to solve for m and n. So again, we'll do the same thing we did in the previous problem. I'm going to use sine. I'm going to use the opposite here, and we use the hypotenuse times the sine of 20 degrees. It's going to be the opposite would be n. And then I can do that again for m. I could say 40, the hypotenuse, times the sine of 70 degrees, and the opposite side to 70 is m. So there's my two equations to find n and m. Pretty straightforward. We just have to do the math now on the calculator. So we would say 20 sine times 40. This could be 13.68 is n. And then we do the same thing. We say 70 sine times 40. And that's going to be 37.59 is the value of m. And those are the solutions for that problem. We're rounding to two places. unless you are otherwise given instruction to do so, to do something different. Let's do the next problem. All right, so the calculations on this are done correctly. This is the right answer. So I will go in and manually correct that. But seconds is not abbreviated, and that's why it marked it wrong. Also, you don't have the 12 in parentheses. Typically in the denominator, we put everything in parentheses. So do that, and I'm going to double check and see what the system actually calls for. The calculations are correct. Hold on just one moment. All right, so the one that it's looking for is the one with the S. That's what it wants. And we typically just put everything in the denominator in parentheses because of the way we format the denominator versus the numerator, especially when you have factors down here. And in the numerator, the only factor we don't put in a parenthesis is the original factor that we start with. Everything else goes into parentheses to show multiplication. And the reason for that is so many times we have a formula. Like if you've changed something from cubic miles to cubic feet, everything in the parentheses is going to be the same. For the next time you change something from cubic miles to cubic feet, you just change the number you're converting. So if we wanted to change, by that I mean, if we wanted to change, let's say 60 inches per minute to feet per second, all we would do is change the number 200, and then it'd be 60 feet over 1260 seconds. That's literally all you would do. It's the same formula. You just change the number of what you're converting. As long as this remains the same, then all the rest of this remains the same and the number just changes out. So that's why we put everything else in parentheses, because then it looks like a formula and it's still a factor, but that's just the way Saxon formats it. He's trying to identify and show you which parts are going to be the same and which parts you can change out, which parts you can write down as a formula through the use of parentheses. So if it's a part of the calculation that is not the original number, put it in parentheses pretty much every time. Okay, next problem. Okay, these are kind of fun to me anyway, because I'm a nerd. So the thing that you have to remember is that you've got to have the same base or else you can't calculate that. But we can get the same base through the use of exponents. So we would rewrite this right away as 3, and this would be 3 squared, and then another 3. So now that we have these two bases the same, we start with the innermost one. We write it in the same location that it's at. We put parentheses in place of the radical sign, and then we write, this is written one time and it has an index of 2 because that's the little number that would be right here. When there's not a number, the number is 2. Now we write this one exactly the way it is. It's on the outside of the radical, so it's on the outside of the parenthesis, and it's got its own radical around it. So we put its own radical around it, and then we write the index. The index, this is written one time with an index of 3. Okay, that's how you need to address that. Even if this has an exponent in here, you write the exponent with the base, and then you put that out here. Okay, this exponent does not go here because there's not an exponent here. If the exponent, if there was a 9 here and a 9 here, and you wrote this as 3 squared, then you could put the exponent on the outside. But because it doesn't apply to both of these bases, you can't apply it to both of the sets of parentheses. All right, now you just multiply, and that's pretty straightforward. So this would be 3 over 2/3 times 3 and 1/6, right? Because 2 times 3 is 6. We want to make sure this matches, so we multiply by 2 over 2. So that would equal 3 and 4 over 6 3 and 1 over 6, which equals 3 and 5 over 6. All right, now we're going to look at this one. So we've got 2 separate radicals, so that's pretty straightforward. We just write a radical and its fractional exponent, and the other radical and its fractional exponent. Just like that, we multiply 2 and 1/4, 2 and 1/3. We need to get a common denominator, so multiply by the other denominator. That's going to give us 2 and 3 over 12 times 2 and 4 over 12, which gives us 2 and 7 over 12. Straightforward. Those are fairly straightforward. All right, next problem. All right, we have some more of these. So same thing, you just write whatever it is, put it in parentheses. That parenthesis takes the place of the radical, but we have to account for what the radical is doing. And then we're going to do the same thing for the next radical. And this is what it's doing. So now we just multiply. So we would have x 2 over 2, y 3 over 2, x 1 over 2, and y 4 over 2. So if I add my x's together, I get x and 3 over 2. Their denominators were the same, so that made it easy. And these denominators are the same, so I get y and 7 over 2. That's it. That's all you have to do. Easy peasy. All right, now let's look at the second one. Right here, we'll do it beneath. So we have xy, and it is written to the 1/3. And then we have times xy written to the 1/2. So we just multiply. X 1/3, y 1/3, x 1/2, y 1/2. But we've got different denominators for the same base, so we need to multiply by the opposite denominator. So that gives me x and 2 over 6. And if I do this, I get x and 3 over 6, y and 2 over 6, and x, I'm sorry, y, should be y, not x. Y and 3 over 6. So then we just add them all together, and I get x 5 over 6, y 5 over 6. And that would be your solution for that one. All right, let's look at the next problem. And that was the last problem. So if you have any more questions, please continue to ask. I will, I'm not going to be available all the time, but I will check in on mornings that I don't have anything else happening, just to see if there's any messages. So you may have to wait more than, a couple of days to get some responses back, but I will check for sure, and until the 31st, because that is when all the pods close and lock down for the semester. All right, I will see you guys. Have a great Christmas. Have a happy new year, and I'll see you next semester.